Welcome everyone. We are here to present our final project titled The Global Trade Network Analysis. We have made use of most of the network science concepts that we learned in the class to analyze the global trade network and gather some interesting insights out of it. Any country's economic success is most dependent on how well they participate in the global trade and supply chains. Countries that are open to international trade tend to grow faster, innovate, improve productivity, provide higher income and more opportunities to their citizens. On the other hand, increased integration into global trade economy and over-dependence on global supply chain may not be a very good idea. In this context, we picked up three important commodities for our analysis, namely fossil fuels, agricultural products, and metals and minerals. When the war between Russia and Ukraine began recently, many countries were outraged by Russia's conduct and put economic sanctions on Russia. Many news articles and experts' opinions have suggested that many countries, particularly the European ones, are heavily reliant on Russian oil, gas, and other natural resources. Sanctions may result in global economic downturn and recession. We thought this was an essential topic, so we started to look out for trade networks for the three major commodities that I mentioned earlier. As you can see, the global trade has impact on many facets. Here are the few goals that we set for ourselves for analysis of the trade network. We wanted to answer few critical questions like, are there any clusters in the network? Which are the most important nodes in the network? Does the network follow preferential attachment? And many more. Coming to the first question, we computed the modularity scores for all the three networks to divide the network by community. You can see here there are few major factors that influence communities formation in the trade network. We observed that the fossil fuels network modularity score was comparatively on the higher side at around 0.5 mark. In this slide, I've shown the communities in global trade network of fossil fuels. We can see four distinct communities in the map. We can notice that the communities formed here are more or less aligning to the geographic locations of these countries. As per the network data and this map, Russia is a major fuel exporter to the European countries. We talk more about clusters that are forming in other networks in the project report. The next question we picked up was, is there any indirect trade between countries? For this, closeness centrality has been used. We can get the nodes that have the shortest path links to other nodes of the network. In this slide, I have shown the top 5 countries involved in trade of fossil fuels by closeness centrality. This finding of ours is extremely important. For example, some new technology or innovation is at hand. Then, if we want to spread it across the world as soon as possible, then these countries with high closeness centrality can contribute to rapidly spreading it across the world. Now, I am handing it over to Vivek to continue with the presentation.
So next, we wanted to answer the question that who are the most important countries in our network. So what we did is we calculated betweenness centrality for this. So for example, here if we remove one country from the trade network, how the other countries would get affected. So in the light of current events, crisis happening between Ukraine and Russia, many countries have led sanctions on Russia, and if Russia is and has a high betweenness centrality value for that particular commodity, the whole trade network is bound to get affected. So here we can see the results for fossil fuel for different communities, and we can see the top 5 highest betweenness centrality values. So here we can see Netherlands and France have the highest betweenness centrality in the global trade. And if we remove them from the network, many countries would be affected. So next, we wanted to answer a question that means that when a new countries is being attached to the no, our network, which country they would most likely be attached to. So in the past 20 years, we can see there is a exponential increase in the number of countries in our international trade, and that is possible due to globalization. So we wanted to understand, are these countries being traded with the popular countries or not? So we did a preferential attachment test for this. So we started from a data where we had an edge list of exporter and importer countries along with its value and its weight. And we transform it into a data that has been shown in the diagram here, which tells us about the degree centrality of each exporter countries along with its category, that is a high degree node or a low degree node, and that is classified based upon its degree centrality value. If the degree centrality value is greater than zero point 0.5, we have categorized it as an high degree, else it's a low degree node. So what our results tell us here is that the high degree nodes over the period of years uh, tend to increase their degree centrality value. So that would mean that the new countries that are coming in the network are likely, very likely, to be attached to the popular country. And that makes sense in real world also, because there are only a few major exporters of fossil, and that we can see that in our next slide as well. So Sharad will take over from.
Hello everyone. Here we can see the top exporters and importers for fossil fuels commodity, where we calculated the value of trade over the last 20 years from 2000 to 2020. Saudi Arabia has the highest value for exporting fuels, which is followed by Russia. United States and China has the highest trade value for importing fossil fuels. The top exporters and importers for agricultural products have been shown. USA, which is then followed by Brazil, are the countries with the highest trade value for exports of agricultural products. The countries with the highest value of trade for imports are China and USA. Yet the top exporters and importers for metals and minerals can be seen. Australia being the country with the highest trade value for exports, which is then followed by China. And the country with the highest trade value for imports is China, which is then followed by the United States. Here we calculated the consistency of trade between different countries. We used coefficient of variation to find out how consistent the countries are trading with each other. Coefficient of variation is the way to measure how spread out the values are in data set relative to the mean. Simply the ratio between standard deviation and the mean. In real world, coefficient of variation is often used to compare the mean expected return of an investment relative to the expected standard deviation of the investments. This allows the investors to compare the risk-return trade-off between different investments. The following graphs represent the top countries which are consistent at each other with trading commodities like metals, fossil fuels, and agricultural products. Recent events of war between Russia and Ukraine have affected many countries like Poland, who have been consistently trading with Russia to import fossil fuels for many years. This can be explained from the coefficient of variation we generated for Russia over the last 20 years with the following countries. Here we calculate the frequency of trade between different countries. Either the countries have been constantly trading for 20 years, or it is a short trade period where the countries have been trading only for a year. We calculate these values for each unique link between different countries. Here we are showing the animated graphs of 20 years of trade data for metals and minerals commodity. The process included loading the spreadsheet data of the nodes and edges into Gephi to produce a dynamic graph. The nodes represent the countries, and the edges between these nodes represent a trade link between them, along with the value of the trade that occurred between those countries as the weight of the edge. Where it shows as the exporter and the target as the importer, and the timestamp as the year when the trade occurred, and the weight as the value of the trade. The timestamp column is used to animate the network here.
So to conclude, we can say that we found some useful insights from our analysis. The first thing is, we found out communities, and we found how these communities might be found, and we mentioned some of the reasons in our slides above. The next is if we wanted to test how good is a country to spread innovation to other countries, closeness centrality would help us determine that. And next would be betweenness centrality. That told us how important a country is to that network. The next thing we did is we did a test for preferential attachment that told us that if new countries are being added into the network, then they are likely to be trade with popular countries. The next is we calculated coefficient of variation for each pair of the countries that told us how consistently they trade between each other over the years. The next is in future work, we can do something like link communities where we find multiple communities for a country, and also we can do apply link prediction techniques. Thank you.